Bringing React Native to the next billion devices, and a billion sounds like a very large number and almost a fantastical number, like an imaginary number. But I think if you take a look at the reach of Android phones and low-end Android phones and Android set-top boxes and things like this, React Native already reaches a billion devices. So this isn't crazy town, banana pants, as Gant would say. But I'm Matt Hargett. My Twitter is SYKE. I'm on GitHub as Matt Hargett with no underscores. And a little bit about me. I've been programming for over 30 years now. My mom was a programmer and a gamer as well. So we used to type basic programs into a crappy old computer called a TI-99-4A. That was the first computer I programmed in the early 1980s. I've been working with React for about 5 years. I did a React project that was a rewrite of a backbone and handlebars web application. Didn't do React for a little while. I worked at LG on WebOS and their Enya JavaScript framework as a technical program manager. Came out of that, and which led to the next project, which was to rewrite my previous employer's main Windows client. They needed just to throw it out and start over again. And I had done React, and then I heard of this thing, React Native, and I'm like, I don't even understand. How would you do native React? Because React is JavaScript in a browser. Then I read about it, I'm like, oh, this is really cool. And then I found out there was a React Native Windows. And so that previous employer had a lot of Fortune 100 companies that had huge fleets of Windows 7 laptops, dual-core Windows 7 laptops with spindle-based disks. So that required a certain performance profile from the application. There wasn't a lot of cycles to give up and things like that. And so they had a large corpus of JavaScript code, and I thought that the kind of a little bit of a moonshot would be to port React Native Windows, which only supported Windows 10 at the time, to Windows 7 and 8. And that worked, and they shipped their new client, and that was really cool. And Windows doing that port to Windows 7 and 8 brought the reach of React Native to 400 million more devices. They aren't mobile devices, they're desktop devices. But that's still a huge reach, especially if you're making enterprise enterprise software. But just to be clear as well, I was building on the work already done by the team at Microsoft. There's a really cool group that they had that people just did a lot of really great open source work. And so Eric Rosell, Matt Podwasaki, Eric Schlegel, and then Mike Grabowski, as he mentioned, did the RNPM work that allowed us to have out-of-tree platforms, which is not something that I don't think anybody was thinking about at the time. And so there was also just lots of help from Eric Rosell. We kind of went to Microsoft and Eric Rosell and was like, hey, we know you really want people to use Windows 10, and that's kind of the point of this React Native Windows thing, but we think this is a really practical solution because Windows 7 is going to be around for a while. It's just a good OS. It's just good enough. There's not a reason for a lot of people to upgrade. So I led that port, but had a lot of help from Eric Rosell at Microsoft and a lot of help from Infinite Red as well, Gant Laborde and Kevin Van Gelder and Leon, whose last name I can't remember right now. So that job ended. They did ship their client, so if you go download their video meeting client now, that is a React Native Windows app, which is pretty neat. The Hail Mary pass worked in that case. I've been working at Sony for 1 year. I am a principal software engineer in the client group. The client group touches everything that basically interacts directly with the user. So everything from the websites, the PlayStation Store on the web and the mobile web, to the mobile application. The PlayStation mobile application is a React Native application, including the UI that you see on the console. Not the games, but just about everything else that's there. And that's pretty cool. My husband and I have been PlayStation gamers for 10 years, and I don't mean to sound corny, but it is an incredible thrill to be working at PlayStation on React Native. It's like really neat. Thanks. So I live in San Francisco with my family, and you can see the picture here. That's me and my husband. We've been together for 18 years this last June, and that's our daughter. She's 3. She just started preschool a few weeks ago, which is very exciting. Some people don't know me from React Native. They know me from my indie music that I do, The Making of, which is the worst SEO band name I could have possibly chosen. Most search engines find it pretty good now. It's on Spotify and Tidal and every digital storefront you can think of. So check that out. So I can get a 1/1000th of 1 penny for every 1,000 streams of it. And I'm an avid video gamer. My mom was a gamer. She got it into my blood, so that continues to this day. So here's the agenda. This might sound abstract, but I will get to the point very quickly. Learn once, write anywhere, and sharing design leads to sharing code. And then what are the tools for sharing that code? And then I'm going to show you a demo, which is kind of a tour of source code. So learn once, write anywhere, right? So everybody knows this phrase is kind of the catchphrase for React, and then for React Native when React Native was introduced a few years ago. And so just the kind of quick rundown, right? So on the JavaScript side, we have JSX, and it's not really JSX is not the point here. You have a declarative thing like JSX or XAML or QML that allows you to do tag-based composition. You have your component lifecycle methods, your component did mount, your those kinds of things. You have your built-in components like your text input, your image background, your touchable, those kind of core primitives. And then you have RxJS and observables or any other stream-based kind of pub/sub sort of thing. And once you kind of have those concepts on the JavaScript side and you kind of know those things, you can do quite a lot on a lot of platforms, whether that's React in an Electron container or a React in mobile web or a React Native web on mobile web or on a Windows desktop or on an Xbox One. Xbox One is a Windows 10 device, so React Native Windows works on that also, as well as iOS, as well as smart TVs that run Android TV, et cetera, et cetera. And then on the native side, these things that are not implemented in JavaScript, right? These are implemented on the native side. Simple things like async storage, fetch and WebSocket, and then there's also Rx.NET, Rx Java, Rx Python. There's ReactiveX everything, basically, for every language that you can think of. And so if you kind of like know those APIs, you can do quite a bit. Maybe should have put Flexbox in there, but it's too late. I'm already doing the talk. So these kinds of the syntax of JSX, the way that the component lifecycle methods work, et cetera, there's kind of having a stream-based pub/sub, whatever that ends up being in your context, whether it's RxJS itself or something like it. There's a couple of key principles, right? One-way data flow, immutability, right? These are the things that allow you to be fast but very safe with some amount of overhead, but that allow you to get that asynchronicity that is so key, right? And asynchronicity is at a very high level helps keep our JavaScript thread free so it can respond to the user and all of the user's interactions. And then you have whether you want to frame it as reactive or observable or cancelable. Let me see. These things are really important because reactive design, instead of cancellation baked in, allows to abort fetch requests. And if the fetch request already happened, at the very least, not parse a JSON payload that we're not even going to show. So when I navigate away from something and a fetch has already happened, either cancel the fetch, give me back that network socket, put that back to the resource pool, or at the very least, don't spend my JavaScript thread time parsing JSON I'm not even going to show the user anyways, right? And then Flux and GraphQL for your kind of state management, Flux pattern implementations like Redux and GraphQL give us seams for extensibility via middleware and things like that. Field serviceability because you can persist persist basically the state of your application, upload that to a server after you scrub it for any person identifying information, and that can be really useful for debugging things in the field, but also for offline first applications, which some of the speakers have been really passionate about in the past. And you can violate these design principles, right? You can do things in React or Redux or in async Redux middleware or in GraphQL that make it so you don't have one-way data flow, so that you violate immutability. But if you're doing that, I would say that you're using the wrong framework. You probably want to go back to backbone views if that's the kind of stuff that you're going to do. So if you feel like you needed to violate these principles, you might want to ask yourself, why am I fighting the framework? Am I just using the wrong thing, potentially? So with those things as kind of the foundation, it's not fantastical anymore to say that you can share 80+% of your JavaScript code between React components, higher order components, navigation, various libraries, state management, experimentation like A/B testing, and analytics. You can share all of those things across React Native Windows, React Native iOS, React Native Android, React Native for mobile, React Native Web, React Native DOM, you name it. I remember when I first started looking at React Native a little over 2 years ago, 2 years ago, there's this idea that this could happen, but nobody had done it yet. But at this time, it's almost passé to say, because everybody has seen this. People are shipping apps every single day, more and more apps used by hundreds of thousands, if not millions or tens of millions of users that are just doing this. So this is like I don't want to say that's easy, but it is highly replicable. So what do we mean by write anywhere? So today what we have is Android, iOS, web, Windows 10, and just a quick reminder that Xbox One is a Windows 10 device. But also Android doesn't just mean mobile. There's plenty of set-top boxes and smart TVs that run Android TV. So one thing I'm going to harp on is just think beyond mobile. One thing I used to get all the time is with React Native Windows, like React Native Windows, nobody uses Windows Phone, and I'm like, it's not about Windows Phone. It's about the 500 million Windows desktops and reaching those users. So there are apps shipping today that are sharing React application code across some or all of these platforms today, right? That exists. And there's one little asterisk on some of these extra platforms. So there's also tvOS, which is in tree, that's in the React Native tree. There's a whole bunch of if-defs and stuff to make it, it's kind of a little if-def port from iOS. There's Mac in React Native macOS, which is a straight up fork, copy of the entire React Native tree. And then there is one for Linux as well, that's StatusIM, which is a company, they forked the Ubuntu React Native desktop project. I have asterisks by those because I couldn't find anybody who is shipping apps on those platforms that share code with other platforms. So they do exist and they do work, so I am told, but I couldn't find a credible experience report from someone who had used React Native macOS to share code with their React Native Android app. I'm not saying there's no reason that couldn't happen, I just couldn't find it, and I like to present credible things, so I include this just for completion so people wouldn't ask where's tvOS. So this is awesome. We can share 80+% of our JavaScript code across all these platforms, but there's more that we can do. So let's talk about the sharing gap. So we're sharing all this JavaScript code, that's great. That means if I've got 90% unit test coverage in that JavaScript code, I've got a really solid base. I can do continuous deployment. I can do over-the-air updates using code push or other technologies like that in a continuously deploying fashion and feel really safe about it, et cetera, et cetera. I can use React Native Web so I don't have to run an expensive simulator to be able to get a reasonable integration test off device. That's awesome too. That's another way to not have to have a Mac to do your iOS development. You just use React Native Web to do your integration testing. So that's all cool, but there's stuff on the native side also. So there's fixes on the native side. There's leaks, there's races, there's error propagation problems, there's algorithmic bugs or optimizations, and then there's just plain old optimizations as well that aren't algorithmic in nature. And this might sound hypothetical, so let me make it really concrete for you. So Yoga node leaks due to UI manager logic bugs. Those pop up on a lot of these React Native platforms, including the in-tree ones. Races, when you add or remove views, there's a pull request that's outstanding right now that people keep chiming in on, saying like, hey, I've had this crash for months and months. When is this PR going to get merged? That's the daily mantra of some React Native contributors. Error propagation via promise rejection, like when async storage has an error, the device ran out of disk space, or your phone got hit by a spinning neutrino the wrong way and the ECC RAM did the wrong thing, and so async storage returned the wrong value, and then for various reasons the exception propagation got cut off because there was a catch that was written incorrectly, but the promise at the very top of that chain in the JavaScript doesn't get a reject. So you think everything is great, but everything wasn't great. Your attempt to store something actually failed, or retrieve something from the store actually failed. Retaining nested stack traces for actionable crash analytics. In React Native Android in particular, and this is a thing sort of with Java and its developer ergonomics a little bit, is that sometimes you can have a nested stack trace, but there are were several points in the code where that inner stack trace will get wiped out. So when I get that crash report on the other side in Hockey app or whatever you use for your crash analytics, it's not actionable by the developer. There's nothing that they can do. And on top of that, it's in the React Native code itself. There's JavaScript code that they can edit. So now you need someone who knows Android Java really well, but they can also fix that problem and get it pushed upstream. Otherwise, you're going to end up maintaining a fork, and no one wants to do that. And there's other things like this as well. There's some more examples I have here in my notes, but some of these bugs, were found in React Native Windows. We fixed them there. Some of them we tried to then take over to Java and React Native Android that's written in Java. Sometimes there's fixes in React Native Android's Java that we bring over to C#, but we're not perfect, and we always we miss stuff. Then you have the React Native Mac OS, which doesn't really keep up in that way. They don't monitor the repo. It's the maintainer that doesn't have a lot of time, unfortunately. And then there's the status IM port, which is all C++, which is completely disconnected. And so there's things that they miss out on as well. And I'm not trying to disparage like their talent and their amazing efforts and their achievement. By the way, the clock's not counting down, so I have no idea where I am. I just noted, I'm like, hey, how much time I got? Oh, 30 minutes. Time flies. So this is just hard to do. And so there's other thing, there's inconsistent unit test coverage of native code between these different out-of-tree platforms and even in-tree platforms. The Objective-C code has different unit test coverage than the Android Java code, et cetera, as well as the new C++ code. I'm going to skip the part on differences in JavaScript executors, but even the difference between iOS 11 and 11.1 and 11.2, you might make what you would ideally want to do is to make a bundle for each one of those, but that's not something you're realistically going to do. So what if we could share just 30% of the native code across Mac, Windows 7, 8, 10, Linux, Samsung, Tizen, Nintendo Switch via Unity, Raspberry Pi 2 and 3, FreeBSD, your mom's 50-year-old toaster, et cetera. So I don't list Android and iOS in here because they have unique constraints due to the platform holder requirements, right? But there is some base C++, code can be and is shared between them. That's something Facebook is already working on, and we'll talk about that in a second. Unity doesn't actually have a JavaScript runtime. I have Unity here under the Nintendo Switch bullet item. Unity doesn't have a JavaScript runtime, but there is a JavaScript runtime on the Nintendo Switch that they use for their embedded browser for stuff. So for any Unity platform that you would want to share native code on, there'd have to be a JavaScript runtime on the platform that you can access from a Unity application. So what's that 30%? So there's the JavaScript bridge, the bridge between JavaScript and native. There's the bundle loader, the JavaScript executor, and then you have native modules, but native modules can mean a lot of things, so let's be specific. So synchronous call support for native modules, remote execution and debugging, error propagation and promise rejection, which we talked about. There's some bugs around that in the different platforms that's a little incongruent. Async storage, WebSocket. And then even JavaScript modules like the hot module reloader client and timers and stuff like that. Basically everything up to where the code gets specific to the UI library or the threading or the dispatcher, that's platform specific. So the core execution, debugging, profiling can be shared to maximize stability, field serviceability, and other key aspects of the developer experience. And I'll show some code in a second that demonstrates that. And one thing to note here is that you can do this in a way that the bridge is totally decoupled from the UI. Yoga doesn't even come into the equation as a dependency when you couple all of these little bits together. So if you want to render out to SNMP MIBs or some other to a message bus or some other kind of non-typical UI, you could do that without having to bring Yoga and a bunch of other stuff along for the ride that you don't want or need. 30% is good, but how about 80%? How would we share 80% native code across Mac, Windows, Linux, Samsung, Tizen, Nintendo Switch, Raspberry Pi 2 and 3, and FreeBSD? Well, if you're using a UI toolkit like Xamarin Forms, GTK Sharp, Qt Sharp, any UI toolkit that has a C# binding or a C or C++ API that has mostly plain old data types in it, then you can get most if not all of the view managers and everything else along for the ride and get about the same amount of native code sharing that we already enjoy on the JavaScript side. And again, why do we care about sharing native code? It's so that when someone fixes a bug that makes it so an async storage failure will actually result in a promise rejection, so that your app can do the right thing and not continue to try to write to a disk that it can't write to, things and stuff like that, that we fix it in one place and all of these platforms can get that fix. One thing I would note here, different UI libraries have different levels of expression. Like some people have a preference for a tag-based library, et cetera, or complexity or code size. And some of these libraries have different licensing constraints, like Qt. And maybe your business plan isn't compatible with those licensing constraints. There's no one right answer for every business and application. Just want to be clear about that. That's why I list a couple of options here. Another thing here is that if you're going to go across between like C# or .NET and native a bunch, you want to make sure you're not having to marshal stuff back and forth at 60 hertz. That's not a very effective use of battery life. And sometimes it's not about battery life. Sometimes it's about like not wanting the fan to spin up on the laptop so that it affects the microphone if you're in a video meeting or something like that. So how do we share that native code? Well, the first thing is Facebook C++. So Facebook already has cross-platform C++ in the source tree today. And some of this existed before the Fabric work began, but now all the Fabric work is being done in this cross-platform C++ as well. C++ can be distributed using a VC package or with CMake projects crammed into the NPM package so that you just compile those. You do your NPM install of React Native. It has that cross-platform C++ in it. Your Xcode project references its generated CMake project file, and you just build it that way. That's effectively the way the React Native Windows works today. Then there's shared projects, which is a .NET construct, and actually came out of Xamarin and not Microsoft. Shared projects basically, instead of having to symlink, have a bunch of symlinks out to shared files that are shared across multiple projects. Shared projects will basically allow you to have a list of files that you reference from another project, and it's as if you were inlining those files into that project. It's actually pretty neat. And then netstandard libraries. So netstandard, I'll get into in 1 second, allows you to write 100% cross-platform C#. And if it compiles, it'll run anywhere. anywhere that there is a .NET runtime of a certain vintage or newer anyways, which is pretty spiffy. When we first started to do the port of React Native Windows to Windows 7 and 8, we tried a technology that was available at the time called portable class libraries that had the same idea, and that did not work for us. The tooling wasn't quite there. Netstandard is kind of the evolution of portable class libraries. And so you could access all of these kinds of tools or all of these capabilities in Visual Studio Mac or Windows, the .NET Core CLI, MonoDevelop on Linux, JetBrains Writer IDE, which is also cross-platform for Mac, Linux, and Windows, or VS Code. So Facebook C++. So this is a little bit weedy because this is really like maintainer stuff or contributor stuff rather. So if you want to look at Facebook C++, you can go to that URL and go poke around in the React common tree. And there's a CXX React. That's something we're going to look at a little more in a second. And then there's the Fabric stuff. And I would encourage people who have a vested interest in React Native over the next year to keep up with that Fabric directory and look at the interfaces that are being checked in there to just stay on top of the re-architecture of React Native that is going on right now, that is known as Fabric. One second. Right, and if we could publish a C++ using VC package or with CMake files, that would be even better. If we can avoid a Git submodule, which is what we'd have to do today, that would be swell. Then there's shared projects. So you can have common C#, C++, or even F# if you're functional curious, like so many of the young kids are today. And so in React Native Windows, this is how we share 60+% of the code between Windows 7, 8, and 10, is using these shared projects. And we also share a lot of the unit tests. And so you can see there's a React Native.shared and a React Native.shared.tests. That's how we share a lot of that code without having weird symlinks across a bunch of directories and stuff that would otherwise be unmaintainable. And for when there is less than a 3-line diff between the platforms, because Windows 10 and Windows 7 aren't that different in a lot of the cases. Sometimes the namespaces just changed, but everything else is the same. And then I would ask, why'd you bother to change the namespace? But that ship has sailed. So in some cases, we use a lightweight pound-if for a build time specialization. Instead of having to extract an interface and make subclasses and a bunch of stuff just to change one line, we use these pound-ifs. And something I would note is that if you don't know C#, you might go pound-ifs, oh my God, C++ macros, gag me with a spoon, I want to cut off my own leg and die. C# only has these basic build time directives. It's not a full macro system. And it's one of the reasons that C# builds are so much faster than C++ is because you can do these kinds of switches and that's about it. And this example code here, this little snippet, is from the dev server in React Native Windows. I just want to talk about why C# and C++ are a good fit for this kind of thing, for having this kind of cross-platform thing. The C# language has runtime type information for fast, accurate reflection. Java does not. Java does type erasure. Has first-class functions, supports strongly typed generics, or parameterized types, and the generics support contra and covariance. And if you are writing a reusable libraries and you want those libraries to be well encapsulated, like being able to really have a separation of concerns, keeping yoga out of the bridge, and being able to ship just the bridge by itself in its own library, you do need these kind of very nerdy type system features. P.S. Neither TypeScript nor Flow have contra and covariance. Let's see. So an example I'm going to show you is that first-class function support allows us to have a one-line factory injection for late binding, which is something you do in JavaScript all the time. This thing isn't ready. This thing is not going to be ready to be used, but I need to pass it in because I need to construct this other thing earlier in the lifecycle of the application. So it allows you to have that late binding. And then I'm going to skip the rest of that for now. Right. So contra and covariance. I have an interface I here that has a parameterized type T, and that interface just has one thing, has a function called fn that returns that type T. And then I have a class K that inherits from that interface, and it parameterizes it with a list of strings. And then it goes on to implement that fn function that returns a list of strings. And then there's a class M that has a static function in it that takes as its parameter to another function called G. It takes an interface of enumerable objects. Object is a base class of string. And then what I can do is I can call m.g with a new k. Well, who cares? What does that mean? What it means is that I can have this deeply nested parameterized type, and I can, at each level, pass it as a base class, as something I can convert it to. And this sounds weedy and who cares, and this guy's just talking about nerdy language features that he likes. This is actually totally key for being able to have this kind of portability and have this level of encapsulation. Or I couldn't find a clean way to do it anyways. Maybe somebody smarter could do it without having those language features present. NetStandard libraries is a specification of APIs that are supported by all .NET platforms newer than a certain vintage. So you have .NET Core, you have Mono 4.6 and above, you have Desktop.NET, and as well as Unity 2018.1 and above. Over a dozen hardware platforms comprising over 1 billion devices. There are no Windows-specific APIs in NetStandard. It is platform agnostic. So if you compile something as a NetStandard library, if it compiles, it has no Windows specifics in it. You can copy it anywhere and run it just about anywhere. There's over 20,000 APIs, but no JSON APIs. So as you'll see, I end up having to take a dependency on a third-party JSON library all the time. There's a large ecosystem of existing libraries for storage, for WebSockets, et cetera, that we use. And it's governed by the independent .NET Foundation, which is kind of like the Mozilla Foundation governs Firefox and all of the Netscape IP. They did that same thing with .NET some years ago. And .NET Core is all open source, Mono is all open source, et cetera. So the majority of that React Native shared project that we used to share a lot of code between Windows 7, 8, and 10 is now compiled as NetStandard. Hooray! So I'm going to show you some code real quick. And let's see, I want to go here. So this is reactnative.core. This is a NetStandard project. And I've got all of the bridge. I've got the bundle loader. I've got the native module base classes. I've got the native module. I'm sorry? Oh, thank you. What do I got to do? There we go. All right, 1 second. Thank you for calling that out. I appreciate that. So here I've got the bridge, I've got my bundle loader, I've got my JavaScript module base class, I've got my JavaScript module registry, I've got my promises, I've got my bridge, I've got my React context stuff, whole bunch of stuff. I've got my hot module reloader client. I've got stack frame formatters to make my red screens readable and stuff like that. I've got my WebSocket JavaScript executor for my remote execution in the Chromium debugger, which is spiffy. And then I have even the core modules, which I didn't think I'd be able to do, but I finished it on the plane over here, which is pretty neat. So you might recognize RCT device event emitter. That's in there. That's cross-platform. Also native app event emitter, the JavaScript timers. So this core library as it stands today, you can make headless React Native, again, if you wanted to make something that like rendered out to SNMP MIBs or something like that, where you didn't need Yoga. So that's pretty cool. And then, that should, oh, I didn't move that yet. So that's pretty neat, but there are times when a platform might want to actually not reuse that base implementation. They might want to overwrite it. So I also separate things out into a NetStandard library that just has pure interfaces. So I callback, I generic delegate, I invocation handler, I JavaScript executor, et cetera, et cetera. So I don't have to rely on the implementation. I can just share the design. And having maintained an out-of-tree platform before, I can tell you that even if you just follow the same interfaces and lock those in place, you'll have a lot easier time merging changes from the other language or the other platform just because you have kept things relatively aligned. And even more spiffy is that Core has tests. Brought over a whole bunch of tests that we wrote in React Native Windows as we were shipping the application at my previous employer and things like that. So that's pretty cool. There's a React Native Mac here. I wonder what that is. The other thing that I did that I would like to point out is that React Native Core just depends on core interfaces. And it depends on this JSON library, a storage library, because I have async storage in there as well, and a WebSocket library. And that's it. There's no GUI stuff in there at all. There doesn't need to be. I have my UI stuff here in a React Native UI. And I haven't ported over. I'm still working on porting over more and more and more of this stuff. But there is enough stuff here that you can stitch together that you can make a console hello world that runs in .NET Core on Mac today. But one thing that I did, because I have that interfaces project, is that the UI library doesn't need anything from Core. It doesn't rely on any implementations. It only relies on the interfaces. Dependency inversion is really key so that new platforms can have this kind of flexibility. And this is there's no great genius here, by the way. This is all the stuff that we've all read in object-oriented like patterns and design books for 20, 25 years now. But it has a very practical application here. And I didn't have a great genius design and fit the code into the design. The design revealed itself as I refactored the code to get this level of separation. To get the level of separation where I didn't want to bring yoga into core, I didn't want to have to bring UI stuff and couple it with the bridge, et cetera, et cetera. And I've done the same thing for the UI interfaces so that if you don't want to use those implementations, you can supply your own and fork off, but not entirely. I think that that's really important. Can someone give me a hand signal of how much minutes I have? Because this still says 30. Huh? Okay, thank you. Good to know. The other thing I was just going to show you was the C++ code, but you can go look at that on the React Native, Facebook's React Native GitHub. I encourage you to poke around in there. In CXX React, you'll see a lot of the same class names as we saw in the C#. So the goal is to basically get rid of the C# reimplementations of these things and just use the C++ and only have C# where there is not a viable cross-platform C++ implementation that is supplied by Facebook itself. So this isn't all about C# and making everything .NET. It's, Facebook is doing a great job providing us cross-platform C++ that we can use across all these platforms, again, so we can all get bug fixes at the same time. And I will do this and close it up. So summary, sharing more React Native code improves not just the reach, but also the stability of React Native apps. And some of these things like async storage failing and not rejecting a promise, or Yoga node memory leaks that only happen on long-running applications that maybe you don't run into all the time on mobile because the mobile OS suspends and then kills your app. Improving that reach and the stability at the same time is really important. If we improve the reach but not the stability, then there is a chance that there will be more of a negative tide as people try to adopt it, find problems, and then just have a bad experience and drop it. It reduces the fragmentation of the React Native platforms, which right now is not great. And part of that is that doing out-of-tree platforms has not very well documented. There's a little bit of voodoo. There's probably 10 people on the entire planet that really know how to do it end-to-end. And there's a new contributor that is just committed some documentation to help that. So reducing fragmentation is really important. VC package and netstandard, and there's other things here, other options here as well, allow for cross-platform packages so we don't have to have Git submodules, which don't feel great and aren't great in the long term on most projects I've worked on. And following dependency inversion allows design sharing without having to share the implementation. And I think that that's really important. So C++ coupled with .NET Core /mono/.NET Desktop reach 1 billion devices. Between everything that Samsung Tizen runs on, all the other platforms that I mentioned, all the Raspberry Pis, et cetera, it's not a fantastical number. You get well over that number when you start to add it all up. And a rising tide of quality and hardening will elevate all of those platforms at once, so that less people are spending less of their time chasing their own tail, trying to track down something that wasn't particularly serviceable in the field because the exception wasn't formatted correctly because there was a bug that someone didn't port over, or a bug fix that someone didn't port over. So better return on investment for React Native as a technology, and the more that we can all blow into the same kind of sails, the faster that we'll all deliver the experiences that our users demand and at the scale that our businesses demand. And my hope is that this proof of concept shows how these object-oriented principles and some of this modern tooling can extend the reach of React Native. And I'm not hung up on the specific languages or tooling necessarily. And proper packaging and I think avoiding submodules are really key. Submodules are jank, I'll just say it. This is going to be coming soon to an RFC near you. Mike talked about this new RFC repo in his opening talk, and I'm going to push it again here. So I'm going to submit a pull request that starts to hash this out with the Facebook folks. Thank you very much. If you have any questions, you can flag me down here, or you can hit me up on Twitter. Thank you.